right through the air and landed directly on our collision object. So this has worked out to be perfect pretty much. If I keep on playing, you can see that the particles are bouncing off the sphere and then they actually roll down it and pour onto the floor. So that's a pretty good result there. If I reduce the bounce value to 0, and I'll change the variation to 0, you can see I can move this icon and move the particles up a bit. And now you can see they're flowing over the top of the icon. So there you go. That's how you use both forces and collisions within particle flow. One more thing to remember though is that collisions are tests. And that means these particles that have collided are now testing true. As an example of this, I'll use some of the principles that I showed you earlier, and I'll actually make these particles change their display when they collide. So we'll just move the timeline back to 0 so we get nice fast interactive speed in particle view. I'm going to duplicate this event by holding down Shift and dragging it to here. I want it to be a copy, so I'll just use the copy option. I don't need the birth operator, so I'm going to get rid of that. I need the collision operator because I still want the particles to collide whilst they're in this event. Otherwise what will happen is when the particles collide with the surface, they'll become true. They'll get passed from this collision test into this event. Then there isn't a collision test anymore, and the particles will then fall through the surface on the second collision, and also they won't ever hit the floor, they'll just fall through the floor. So I've made sure that I've duplicated this collision test here. And I need the force, I don't need the speed, that will be inherited from the previous event, so I can get rid of the speed operator. As I've said earlier, always remove any items that you don't need because they will slow down calculation. And let's just do a quick test of that. You can see it's acting exactly the same, but now the particles are going to the second event. And you can see that with the particle counter, the particles are being counted as they pass from event to event. And it only happens when the particles collide. Now I haven't changed the display type, so let's do that and then it'll become very obvious that we've actually had a collision. So there you go, you can see particles are colliding with the sphere and then they're changing shape. I'll just make them change color as well. So there you go. Collisions are tests. You have to remember that. That's a very important feature. We'll just cover one more type of collision, and that's with a mesh surface, which is something that obviously most people want to do at some point. I'll go to geometry, and I'll create a geosphere, and I'll keep its pivot point to the middle of it, and I'll just snap it to this particular collision space warp here. So now it's sitting in the same space, and if I go to a left-hand view, I can change the radius of the sphere so it sits in exactly the same spot and appears to touch the ground. There we go. Now I don't want to use this spherical collision gizmo. It's actually ideal for the sphere, but just to demonstrate what I'm talking about, I'm not actually going to use that. We'll just get rid of it. And there's a specific type of collision space warp which we'll look at. It's called the U deflector, and that means it's a universal deflector. So we can draw it into the viewport, and there's our little gizmo. And if we go into the collision operator, you can see that one of the one of the space warps has actually been deleted. So we can just remove that from the list, just to clean it up a little bit. And what we'll do now is we'll add our universal deflector. So we'll add that, and we'll do the same for here as well. If I press play, you'll see that the particles fly straight through it. That's because the universal deflector doesn't actually work as a gizmo. It uses the mesh of another object as its collision surface. So you need to pick an object using the pick button. So there we go, we've picked the geosphere, and you can see that particle flow has updated because we changed a parameter, and now the particle flow is correct for the time. So if we cycle backwards and press play, there we go, you can see the particles are bouncing off the sphere. That's because I didn't change the parameters in the same way as I did with the previous spherical deflector. I left the bounce at 1 and I didn't change anything else. So if I just do that again, I'll have a tiny amount of bounce, tiny amount of variation, quite a bit of chaos, a little bit of friction. And then if we play that, you see we'll get a similar kind of result. Okay, that's all we'll feature on forces and collisions in this particular DVD. If you want to look at those in more detail, then they're covered in much more depth on DVD 4 in this series, so I can recommend that you have a look at that DVD. Okay, let's move on to spawning. Spawning is a common feature of particle systems that allows you to create new particles from existing ones. There are two types of spawn within particle flow, and both of them are tests. The first is called simply spawn, and can create new particles either on a single occasion, as the spawning particle enters the event, or on multiple occasions based on the distance the spawning particle has travelled. The second option is very useful for creating trails of particles, either for an effect, or simply to use as a way of analysing your spawning particles' trajectories. Let's have a look at an example that we looked at earlier. It's quite useful for looking at this effect too. I'll just run through the timeline a bit, and you can see it's producing a trail of particles. As the birthing particles fly through the air, they leave a trail of particles behind them. I'll just bring up the particle view and make it a little bit smaller here, so we can see both. Okay, there we go. Now if I turn off the cache operator, this will actually stop us getting any strange results here when we work with these options. And I turn off the spawn operator, you'll see that the particles now don't have trails anymore. You can just see the original particles. Just move this window up here a little bit. So now if I press play, you can see the particles fly through the air, but they don't actually leave the particle trails behind. That's because spawn is turned off, so the particles aren't being spawned anymore. Now if I move back to the beginning and I turn this on and press play again, we've got our trails being spawned again. So that's pretty cool. Now one very important thing to remember with the spawn test is that the particles created by the spawn are testing true, whilst the spawning particle is treated as false. You must remember that this spawning feature is a test. So as I just said, the particles which are spawned by it are treated as being true, and the emitting particle is treated as false. This allows us to pass the true particles, in other words the spawn particles, out to another event, which is what I'm doing here. You can see I'm using a delete operator to then kill those particles after a random time span. I'm using a very random time span here. I'm using 30 with plus or minus 29. So you can see the particles can live anywhere from between 1 frame and 59 frames. So that's actually quite a big time span. And the advantage of using that is it gives us this big feathered tail to the end of the particles. So this is the preferred method for myself anyway when working with spawn particles, because if you don't pass the particles out to another event where you can kill them off, they can multiply very, very quickly. You've got to remember that when particles aren't sent out to another event, they remain in the event that they were spawned from. And every particle that is spawned is then able to spawn as well. And you can very, very quickly end up with what I would describe as a particle explosion. So I'll just show that very, very quickly, but I'll do it in a frame-by-frame basis so we can see exactly what happens. Because it's quite possible to actually crash max. It can use up a lot of memory very, very quickly. So we'll just go back to the beginning of the timeline. We'll zoom into the source icon to get a closer view of what's actually happening. And I'll just delete this wire here. Okay. Now I'll just step forward 1 frame at a time. So you can see out come the particle. There's just one particle there. And it's not really clear at the moment exactly what's happening. So I'm just going to change one more parameter here to make it easier to see what's happening. I'm going to use inherit speed at the moment is set to 0. I'm going to change that to 10%.